Problem 6. There are 81 grid points uniformly spaced in the square shown in the diagram below, including the points on the edges. Point P is in the center of the square. Given that point Q is randomly chosen among the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? So we're trying to find a probability for where Q can be. So what is the definition for probability? The probability of something occurring is equal to the number of successes over the number of total possibilities. So with this understanding, we're trying to find the total number of placements for Q. Well, it told us that Q has a total of 80 possible points. So the 80 goes in the denominator. But how many possible successes are there? Well, we know that PQ is a line of symmetry. And what is a line of symmetry? If I have a random shape, a line of symmetry is where if I reflect this shape across this line, I will get the exact same thing. So with this understanding, I'll draw my lines of symmetry in red. Let's assume I have this line. That is obviously a line of symmetry, right? Because if I reflect this shape to here, it's the exact same thing. But is this line of symmetry if I connect this dot with this dot? Well, if I were to do this and I reflect this shape over this line, right, I won't get this this other shape right here, right? What I would get is a shape that looks something like this. That obviously is not a line of symmetry because it violates the definition of what a line of symmetry is. Therefore, we cannot have these points. But likewise, we cannot have this point and this point. We cannot have this point and this point connect together because the line of symmetry, again, will not reflect over to get the same exact shape. So our next best thing is where we connect this line right here. Y is equal to negative x. And then we can obviously have y is equal to positive x right here. And we can also have this line and, oops, sorry, that's a bad line. Like that. That's the roughly drawn lines of symmetry that we can have. So basically, as long as Q lies in one of the dots that these red lines touch, then that will be a proper point because then that would create these lines, which is what we want. So how many of such points are there? Well, we cannot include P. So how many other points are there? I'll do it in green. For this vertical line right here, we have 1, 2, 3, 4, 5, 6, 7, 8. And what about for this line? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute, we have 8 points per every line. So how many lines do we have? We have 1, 2, 3, 4 lines. So we have 8 times 4. This is our total number of successes. This is our total. Therefore, it satisfies this definition of our probability. So this is our correct answer. That's 4 over 10. That's 2 over 5. Your final answer is answer choice C.